Hi, I'm Mason Brasher, Chief Programmer at MACH Robotics. Our team used Simulink to program our robot, the Wireless Aquatic Vehicle Entity, due to its simple format and powerful capabilities. Our program was organized into multiple subsystems that allowed for easy navigation. In addition, input, operation, and output sections of the code were all color-coded and labeled with detailed explanations. Lastly, virtual buttons and knobs along with output display blocks allowed us to simulate the code before deploying it to the robot. Our controller layout subsystem organized and labeled all VEX controller inputs. Go to and from blocks were used as wireless connectors to the other subsystems in the program. Our drive subsystem made use of a powerful state flow block to allow for custom coding not possible otherwise. The goal was to create a program that controlled a wheel with two possible speed settings. This was achieved easily with two major states, one giving an output equal to the input, and the other giving an output equal to half of the input. The two states had transition states in between that sensed when a speed control button was pressed and released. In addition, however, the team wanted to make a deadband type function to eliminate small accidental inputs. This was accomplished using a MATLAB function block within both of the major states. This function basically canceled out any signal between 20 and -20. But it did not reduce the maximum possible power by 20, as a standard deadband block would have done. Next was our robot arm or manipulator subsystem. The manipulator needed to be able to move up, down, and side to side using DC motors. In addition, we wanted two methods of side-to-side control: quick movement with a joystick and precision movement using two buttons. All of this was easily accomplished by running our button inputs through gain blocks to give them the ideal signal strength, then by connecting them and the joystick input with add blocks to the motors. Our claw or end effector subsystem needed to control a single motor that would open or close the claw. Secondly, it needed to stop opening or closing when it reached one of two limit switches. Digital input blocks were used to connect the limit switch inputs to the program. Whenever a limit switch was pressed, a switch block canceled all signal from one of the two buttons by multiplying it by 0. That particular button then functioned as usual when the limit switch was released. Finally, our robot program contained a trash storage subsystem that would use a servo to release a storage basket into a usable position and then use another servo to open and close the basket. The latter function was controlled with two buttons pressed at the same time by using an AND block in order to prevent accidental opening of the basket, and a latch block to allow the same two buttons to then close the basket. This concludes our video demonstration of the MACH Robotics Simulink program for current events.